Oh, started right away. Yay. Hi, huggers. Welcome to your first video lecture. We are doing lectures this way because it's just not conducive for me to like talk at you for 45 minutes like I would in an ordinary class, which by the way, I don't do anyway. Lectures typically in my class are pretty interactive. It's kind of hard to do that on a Zoom. So I figured this would be a better format to deliver information. Remember, this is an AP class, so you have a lot of content that you're going to be learning, and this is probably the most efficient way for me to help you learn it. So I'm doing things a little differently. So this is probably going to be a longer video than most of the other lectures that I do because I want to make sure that you understand why I'm doing some of the things that I'm doing. So for example, there is a reason why there is a 1.0 on this slide, and I'll explain what that means in just a minute. So I want to start off by talking about what this class is. Now, I know that you signed up for this class, and this is your choice that you're in here. So I'm assuming that you know that this is a geography class, but it is not a typical geography class where we're just going to look at like where places are. Human geography is really about providing people with the tools to analyze all of the things. Like this, everything has to do with geography is really, whoa, is really accurate. Like everything really does have to do with geography. You can literally study anything from a geographic perspective because geography answers the why of where, right? So why are things where they are? How did things become distributed as they are? What is the relationship among the things? We call it phenomenon. So it's just whatever it is that you're studying. What is the relationship among different types of phenomenon? What is changing the pattern of distribution? So like things are changing all the time. And we often talk about how at one point, there was like you might even think about like the Wild West and like the cities that used to spring up all around the West and now we consider those ghost towns, right? Like nobody lives there anymore. I mean, there's a very specific reason why. And then most importantly is that last bullet point, like what are the implications of the spatial distribution for people? So why does this matter? And what you're going to see, well, I hope that eventually you're going to just start seeing like geography sort of everywhere as a result of this class. And maybe you'll think it's really cool because I think it's really cool. But also you might just be like, oh, Truex, I can't get this stuff out of my head. Because really that's like, I don't know, this just helps explain the world. I don't want to get into it right now, but I'll be honest with you. The coronavirus, this whole COVID crisis, is making geography feel very relevant for a lot of people who maybe didn't used to think geography was all that relevant. Okay, so here's what I want to start. My child is breaking into my room right now. I want to start with 1.1. Now, 1.1 has to do with Unit 1, Learning Target 1. That's essentially what this is. So these numbers become really important. So if we were in Unit 2, and this said 2.1, we would be looking at the first learning target in our population and migration unit. So we're in Unit 1, which is just all about geographic perspectives and this idea of what is geography. And it's the first learning target, which is, of course, maps. I mean, maps. Geographers can't do anything without a map. All right, so this is the essential learning for this particular presentation. And sometimes I'll do more than one learning target in a presentation, and sometimes I will just do one. So this is just one learning target. And you can see that this learning target is broken up into 3 different parts. So there's types of maps, there's types of spatial patterns, and that there's like map projections, and that's how we're going to end. And so this is sort of like, you can consider this sort of your roadmap for learning. By the end of this presentation, you should be able to do all of this and explain all of these things. Okay, now there are 2 types of maps. There's the boring maps like these. These are just reference maps. And reference maps just provide general information. Typically they're political maps. Sometimes they're physical features. I guess they're boring because they just don't really tell you the fun stuff. Like a street map is great, but who even uses those anymore now that we have GPS and GIS, and we're going to talk about that next week. So they're important, I suppose, if you want to find locations and if you want to know like where the climate regions of the world are, but they aren't the fun maps. The fun maps are thematic maps. And if you did your reading first, you probably have an idea of what these maps are, but you don't have any visual representation of what the maps are. And so my goal is to kind of show you what they are. So a thematic map communicates information about a place. So what are the spatial aspects? What is it like there? So typically these types of maps will look at a thing and then demonstrate where that thing is located. And then it's going to be up to you as budding geographers to interpret the map and to draw some conclusions about why those things are where they are. So you have to know all 5 of these maps. You have to know a choropleth map, dot density map, graduated or proportional symbol, those are the same. A cartogram or isoline and topographic, those are basically the same kind of map. Okay, chloropleths, by the way, are my favorite. And yes, I have favorite maps. All right, so a chloropleth map is a map that uses colors to indicate patterns. Typically, the darker the color, the more concentrated whatever it is that you're looking at is. So in this particular case, this map is mean years of schooling in 2017. So if you look, and when you read a map, you really have to pay attention to all of the things on the map. So this is the title of the map. This gives you a little bit more information about the map, the average number of years of total schooling across all educational levels for the population aged 25 plus, kind of a mouthful. And then if you look down here, this is what the gradations of the colors mean. So if you're in this dark blue, that means people spent greater than 14 years in school typically. Right. And you can see that when you're looking at this map, again, darker always means more. So the darker colors on this particular map indicate the highest levels, excuse me, or the most amount of schooling that people might get. And then, gosh, that tickled my throat. So when you're looking at this already, you can draw some conclusions, right? So you're going to look at the patterns. Or where are we seeing the patterns? This is really interesting. It looks like Canada, the United States, most of Western Europe, and Australia and Japan. At this point, you should be thinking, those are like maybe the richer countries. You'd be right if you were thinking that. And then you start looking at, okay, now there's like these lighter shades. And you might be noticing like you have most of Russia and you have Mongolia and some other places of sort of Eastern Europe over here. These are the second most educated people. And then you might be starting out like, that's interesting. And then you might also be looking at this, like there's this sort of imaginary line that kind of goes like this, and then you kind of wrap around here. There's actually a name for that. It's called the Brandt line. It's also referred to as the North-South divide, where the Northern Hemisphere plus Australia tends to be wealthier and more educated than the Southern Hemisphere, and there are all kinds of reasons for this. One of the biggest ones is colonization, but we'll get there. So all of this information comes from just a single map. So maps are like very geeky about maps. They're very cool. Okay. This is a dot density map. So a dot density map, well, the thing about a dot density map that's most important is obviously it uses dots, but each dot is the same size. And when you see a higher concentration of dots, like you see right here, this is where whatever it is that you're measuring is like, it's the highest amount. So the title of these 2 maps is Gun Violence in Cincinnati, Ohio. So when you see clusters of these dots, that means most of the gun violence in Cincinnati, Ohio is happening in this part of the city. Now you can change scale, and scale is like a huge part of this class, but we'll get to that like way at the end of this unit. So this is a we call it like a small scale map. So there's like less detail. And then as you get closer, this is a large scale map, so you're seeing more detail, and now you're getting more information about specifically like what streets are we seeing most gun violence happening in this particular area of Cincinnati, right? So you can think of like scale, when you're talking about map scale, like zooming in and out of a microscope, right? But the key to understanding dot density is that the clustering of dots, when you see a bunch of dots all together, or like over here, when you see a bunch of dots all together, that indicates a higher percent, a higher number of whatever it is that you're studying. Again, gun violence in Cincinnati is what you're looking at here. This is a graduated or proportional symbol map, and it uses symbols of different sizes to indicate the different amounts of a particular variable. So it's a dot, kind of, but unlike the dot density map, when you see a greater concentration of whatever it is that you're measuring, the size of the symbol actually gets larger, right? So we're looking at largest foreign-born group in each county. I'm like filming something. So can you get out like right now? That's my daughter and our dog. Sorry. This is really interesting when you're looking at this, and it should come as no surprise when you're looking at this dot down here and these dots down here and these dots down here, that they correlate with Latin America. And that should make sense, right? When you think about where foreign born people are likely to settle. And if they are from Latin America, they tend to settle all along the border of the United States here. And so, again, proportional symbol, it's all about the size of the symbol indicating the higher of the value. Cartograms are silly maps, I think. You won't see these too often, but they are kind of fun because they're so funky. So here is a map of Africa, of course. Here is a map of Africa based on population. So this is the country of Nigeria, and this is the country of Nigeria in a cartogram fashion where the size of Nigeria is blown up to represent the amount of people as compared to the rest of the population of Africa. So when you look at this, you can kind of automatically tell visually where does most of the population actually live in Africa based on how distorted in size the actual country is. So when you look at this map, the first thing that should jump out at you is Nigeria, right? So like in terms of population per country, Nigeria has the highest population, right, of any other country in Africa, which is why it looks so much bigger here than it is actually here. And that's essentially what a cartogram is. And you can see that they did that for the whole world. Our World in Data is like a really cool place to get fun data. But here you can look at, all right, so where does the vast majority of the population live? Which countries are blown up the largest versus which countries are kind of shrunk? Like India is huge. China is huge. The vast majority of the population actually lives in this cluster. But then you come over here and it's like, where did Canada even go? Oh, Canada, you disappeared. Bye bye, Canada. That's because there's just not a lot of people that live in Canada. And so that's what a cartogram will show you, just kind of like messes with the shapes of places. Okay, the last type of map that you need to know is an isoline or an isoline map is, and topographic maps are kind of similar too, depending on which version you're looking at. But an isoline map uses lines that connect points of equal value across space. So like the most typical isoline map is a weather map. So whenever you are looking at a weather map where you're seeing like the trends of the weather, those lines are actually it's an easy way to remember the map too, like lines, isoline. All of the area that's shaded the same color is the same value. And here we're talking about temperature. Okay, topographic maps are kind of like isoline maps too, if you're not looking at one that's 3D. But a topographic map, what you need to know about this is that the closer the lines are, the higher in elevation something is. So when you're looking at this map, this is like a taller point than what you're seeing right here. So the wider the lines are, the less elevation there is. The closer the lines are together, the higher the elevation. Makes sense. Okay, so the second part of like this tour of vocabulary, because that's essentially all today is when we look at types of spatial patterns on maps. And I was debating and debating whether or not I wanted to share this slide with you, and I'm just having a last minute, like I think I ought to. So let me just fix this and unhide this. You're going to see absolute and relative location again in a couple days. So I was going to wait to present it, but it does make sense to do it while we're talking about maps. Let's just wait for that to load again. Sorry. Okay, so absolute location and relative location. You're going to see three different absolutes and three different relatives, and they all kind of connect, and they all are basically the same. When you see something that says absolute, it's exact and precise. When you see something relative, it's like, close, nearby, sort of this way. It's not precise. So when you talk about absolute location, what we're talking about is latitude and longitude. An easier way to remember latitude and longitude is latitude is like a ladder. So they're the lines that go up, right? They're the lines that travel up. And then longitude, think about long. So these are the long lines, right? So like the equator is going to be a longitude line, whereas the prime meridian is going to be a latitude line. Okay. And then the way, I mean, the way in which you find it, it's just like anything else. There's just coordinates on a map. So when you're looking for Rio de Janeiro, which is right here, you're going to go 23 degrees south, which when it says south, that means you're moving below the equator. And you're going to go 43 degrees west. And if you're going west from the prime meridian or east from the prime meridian. So like 0 degrees latitude and 0 degrees longitude is kind of like the springboard point, right? So north of 0 degrees, south of 0 degrees, east. It's going backwards. You get the gist. So relative location means a place relative to another place. So like my house is across the street from the bright pink house, if that existed, or it's between this place and this place. So it's just not precise. You give a lot of times we'll give directions using relative locational like pinpoints. Like you're like, for example, you might be like, you're gonna turn left at the Dairy Mart, whatever it might be. And then you're going to go about, 3 houses down and turn right. That's basically relative location. We describe places with relative location quite frequently, actually. Okay, so another one. So absolute and relative distance, sort of the same thing. So absolute distance is exact. It's precise. It's miles, kilometers, feet. So it's 21.3. Oak Hills is 21.3 miles away from my house, right? Or you can look at scale, right? So like 1 inch equals 1 mile. That would be an example of absolute distance because it's very precise, exact. Relative distance is more about spatial interaction. So the connections between places. So there is despite the fact that there is a greater relative distance between the United States, despite the fact that there's a greater absolute distance between the United States and, say, England, because we have a very close relationship both historically and culturally, the relative distance is actually shorter. There's a lot of planes that fly back and forth and back and forth and back and forth. And so you might look at like our connection, our relative connection to England is probably even closer than, say, our relative distance to, I'm trying to think someplace that's a little bit closer that you guys might, maybe even than Mexico, to be honest, although maybe not recently with the whole renegotiated trade and so on and so forth, maybe Brazil. If you understand what I'm kind of saying, like a smaller country that has less connection to the United States is actually further away because they're less connected. This is an interesting point too. Amazon has really decreased the relative distance between consumers and products too, right? Like, I don't know if you guys order on Amazon or not, but I mean, you can get anything from anywhere like in 24 hours now. So relative distance seems rather like irrelevant at this point. And we'll talk more about that later. Okay. The last one is absolute and relative direction. And again, absolute's precise, cardinal direction. So it's northeast, southwest, or northeast, northwest, southwest, southeast, etc. Relative direction is, again, sort of the same thing. Turn left at the target, then right at the stop sign, sort of thing. Left, right, go straight, whatever that might be. And then you're also kind of talking about relative location too. So all the relatives go together, all the absolutes go together. Okay, and some more ways to describe spatial patterns on a map. So you can describe spatial patterns by kind of looking at like 3 different features. Things are clustered together, like when we just talked about the dot density map, I was talking to you about, I use the term clustering because the closer together it is, the higher the density of something. And in a dot density map situation, that means the greater concentration of whatever it is that you're studying. Dispersal and distribution. Clustering and dispersed. I lost my train of thought there for a minute. Is now become clustering and dispersal. So dispersed just means the things are further apart from one another. And distribution is just how things are spread out, right? So like you might look at this and you said, this is the distribution of this is clustered. The distribution of this is dispersed. The distribution of this is linear. and so on and so forth. Here's again clustered. And then lastly, we talk about patterns and spatial associations. This is sort of the critical point to this whole map thing, right? So like, how are things connected? How are they related? How are they correlated with one another? So I think I did this inadvertently when we were looking at the choropleth map where I was talking about education. How ironic it is that, you know, the northern hemisphere in Australia tends to be more educated and richer and so on and so forth. Well, if you were to look at a map and compare that with like the areas of the world that were colonized by the West, you would see that there's definitely a correlation between those two maps. And we'll talk about colonization in like Unit 4, so we'll get there eventually. Okay, the last part of this increasingly long lecture has to do with map projections and distortions. So maps, all maps, every map is distorted in some way. Why? Because projections, you're taking, with the whole definition of a projection is taking the world, which is round, and making it flat. So when you do that, you have to make some sacrifices as a cartographer who is a map maker, because you can't physically represent a round surface on a flat surface. And so when you are making a projection, and a lot of times we're talking about reference maps when we talk about projections, they distort the relationship in some, they distort some spatial aspect, either shape, area, distance, or direction. So maps are SAD. Get it? SAD, shape, area, distance, and direction. There's a better slide coming up here. Oh, I forgot about this. So this is a geoid, and this is a representation of what the Earth actually looks like. So although it's not flat, it's not also perfectly round. Like, this is the best representation for what the actual Earth looks like. And this like dent in the Earth actually exists. But anyway, when we're talking about projections, we're talking about taking this, which is mostly round, and turning it into this. And so when you do that, you distort things. So for example, this is Greenland. This is Africa. They look like they're the same size. They are not even close. It's the same way that you might think about when you see a head. If you were to unwrap it and make it flat, it would look weird, like this. You're not going to be able to unsee this. I'm going to leave it there just for a minute, just so you can really look at it. It's weird. Like a projection. Okay, so again, map projections are sad because they distort shape, area, distance, or direction. Area is the same as size, so sometimes I refer to size as distorted. I don't mean size because that would make our acronyms, so we'll just keep it as area. All right, so a couple projections that you need to know. This is the Mercator projection. In the Mercator projection, the big distortion for the Mercator projection is size or area, right? Like this map really messes up the size of places, and so it's particularly like when you look at the poles. I mean, this is Antarctica. Antarctica is not this big either. I mean, it takes up the entire bottom of the map. So as you get closer to the poles, and you can kind of even see like the lines of latitude and longitude, how they're stretching out, that would indicate that they're stretching out these landmass areas and kind of squishing these landmass areas together. And this map has a lot of problems, and we'll talk about that like next Tuesday. So you guys are going to do some work with these projections. But it's also really hugely beneficial. I mean, it was created in 1569. The primary purpose of the Mercator projection was for navigation. So it does a really nice job of preserving right angles of latitude and longitude, which makes navigation really like now people can actually find their way to other places. I mean, Columbus didn't do so well with this, but whatever. So benefits is that it's good for navigation. It's actually still used for navigation. The disadvantages is how it distorts, majorly distorts size, area. All right, so Peters is an equal area projection, and Peters was actually created in response to the Mercator projection because the Mercator projection is a little bit like, it's a little bit Eurocentric, we'll just say, and this is a much better map to indicate or to maintain size. So again, here's Greenland compared to Africa. But now what is messed up about this map is of course shape. So it doesn't preserve shape, but it does preserve size. And this map was designed to sort of reposition the continents where they're actually at. So if you were to look at like this map, like it really makes Europe kind of like the center of the universe, right? But then if you look at this map, like Europe is way in the northern hemisphere. It's not really the most important place in the world. And of course, Europeans made the Mercator projection, so it sort of makes sense that they put themselves right in the center. But here they are juxtaposed. So this is the Peters projection on top of the Mercator projection. So you can just see how where one might maintain shape and direction, and that would be the Mercator projection. The other one preserves size and sort of location, right, where they are, where places are. And then I'm going to have you on the Edpuzzle. I'm going to put a little link in here where you guys can kind of play with this. So like here's Africa versus Greenland. So Mercator projection, actual. Okay, the Robinson projection, this is like the educational map. So the advantages of the Robinson projection is that it's sort of like the compromise. It's called an equal area projection. So it distorts a little bit of everything to not majorly distort anything, if that makes sense. So its benefit is also kind of its disadvantage, and that is it sort of like streamlines all the distortions, but that means that everything is kind of distorted, just not totally distorted. If that makes sense. And this is it, right? So what is the whole point? The whole point of at least this last part is that all maps are selective and distorted. They all have bias in some way. The map maker has to make a decision on what they want to distort and for what purpose. And then there's nothing really important about the world as a cat, but it is just kind of cute. So that is all for this first of many lectures. Let's see if I can start. Haha, that was long.